everyone, I'm Dan Ivovich, Director of Engineering at SmartLogic.
And I'm Sundi Myint, Software Engineering Manager at Cars Commerce. And we're your hosts for today's episode, for the first episode of Season 14. I can't believe we're on Season 14. We are joined today by Isaac Yonemoto, creator of the Zigler library, CEO of Videla Labs, and friend of the pod. We haven't had you on for a while. Hey, Isaac, how's it going?
Yeah, it's been a while. It's going great.
Today we are talking about Zigler and the Zig NIFs and let's say the Zig code directly from Elixir. I can't believe we wrote this down this way, Dan.
Well, you know.
We're talking about Zig and all things Zig because this season we are talking about the Elixir-verse, the Elixir tangential, all the things that are close and near to Elixir that might not be Elixir specific. So, Isaac, welcome back. How is life? How is it going?
Going good. So I have semi left the Elixir community. I don't actively program for a living anymore. But I'm still maintaining the Zigler library, and I've promised to maintain it until at least 1.0. And that'll happen shortly after Zig goes 1.0, which I don't know when that'll be. Not in my control. So I'm sure we'll get into that later. I'm currently outside of the country. I've left the United States for a few months to work on my startup. So I left Elixir, I left tech, and I'm now doing a biotech company where I'm going to be building drugs for way cheaper. So there are these drugs that cost, say, like $100K to $200K per patient, sometimes per year, sometimes more. And part of the reason why they're so expensive is the manufacturing costs are high. So I'm refactoring the manufacturing to bring the price down to like 10K, maybe even less if I can do really good. So I'm finding one of the interesting things I'm still using Elixir.
Nice.
Just the other week, I needed to do some bioinformatics. And I was like, I don't want to learn all the bioinformatics packages. And I had to do a pretty custom bioinformatics pipeline. And so I wrote my own bioinformatics scripts in Elixir, which I don't think anybody else really does.
No, but this totally tracks for you, though.
Yeah. And it took me like 30 minutes, right? And there was no way I would have figured out how to like do all the incantations to like do the right things and whatever else it was written in. It was so much faster to just do it myself, right?
Nice.
So and like I'm running into like how to like problems of how to like keep lab notes. So kind of in the back of my head, I might be building out like effectively. So I'm currently using Obsidian, which is like a markdown based note taker, and it's actually quite nice. It syncs between my computer and my phone, so I can take a picture of something that I see in the lab and then put it into my lab, quote unquote, lab notebook. But there's just some rough edges that make it like, I mean, it's not annoying enough that like I won't use it. And it's certainly better than almost anything else that exists. But there's some rough edges that I'd like to smooth out. And I'll probably wind up using Elixir to like spin up my own sort of private SaaS for doing size.
Excellent.
And there's some sense in which, like, for what I'm doing, I don't really trust a third party, vendor with the data that I have in that I'll be accumulating. So that'll be nice to like be able to self-host effectively.
Cool.
Yeah.
That's a lot of life updates in
big
like
update.
2 minutes.
Yeah, we covered a lot of ground there.
Yeah.
But everything else is the same.
Yeah, I was thinking about like the last time we chatted, and I think we had you on the show, and there's a note here that says 2021, and while my brain is like, yeah, that was last year.
No.
Was that in fact last year? I think last time I might have seen you was probably at an Elixir Conf in Denver, perhaps.
I think that sounds right.
Yeah,
Sounds right. Yeah.
So that's how life's going for you.
Right.
I remember, so I was thinking back to that conversation that we had on the podcast, because we have talked to you about Zig before. So I guess just for the new listener, what is it? Does it at all relate to work you're doing now? It doesn't sound like it, but I'll let you answer that question regardless.
Yeah, so what Zig is it's a low-level programming language. So sort of like C. The genesis of Zig actually is that the author didn't like how C did a lot of things. So he took the bad parts of C and deleted them and then added back in one thing, which turned out to be quite like it turned out to like increase the complexity a lot, um, but also increase the power like a huge amount. So
Hmm.
maybe like the way to think of it is like it's sort of like in Elixir how you have macros, you can do meta programming. There is a meta programming system in Zig that isn't actually macros. You're not manipulating the code, but you are doing like meta programming. And so Zig offers this sort of third way. So on the one hand, we have like if you're used to see, there are these things called lexical macros, which basically take a snippet of code and cut and paste it. And they're really awkward. IDEs have a hard time with them. You can get yourself into a lot of trouble by, you could substitute like false for true, for example, and every place it says true in your code, it will be substituted with false, right? Which is probably not what you want. Nobody really does that, but it kind of gives you a feel for like what sort of foot guns can happen. But you could also like have a macro that opens a parentheses, and like if you don't have the macro that closes the parentheses or closes the parentheses in a weird spot, it could be really hard to debug. So that's kind of like C style. Actually, Erlang does this too. Erlang has lexical macros as well. And then on sort of the other side, we have AST manipulators where you write some code that will generate code. So Elixir is on that sort of end of the spectrum. And maybe Rust also has like macros where you're effectively writing code. And so that gets compiled into actual code. So the nice thing about that is that you are restricted in terms of like you can't use a macro to write code that's a syntax error. But I would say Zig is even more like restrictive. The meta programming stuff that you can do in Zig, there's just a whole bunch of things you can't do. The essence of it is there are some types of variables that you can only access at compile time. And you can manipulate them, but treat them as variables. And you can also run your code at compile time. So that's the essence of how Zig's like meta programming works. Anyways, it's a low-level programming language. If you want to do stuff like access low-level operating system things, network calls, if you want to go fast, because Erlang does all of its computation in boxed terms, so it has to take this data, say, oh, that looks like an integer. Okay, now I'm going to add it to this other integer thing that might be an integer. It unboxes the integer from that, and then it does the computation, and then it has to rebox it back into an integer. So that's like a very steppy process, right? That's part of why Erlang is, quote, slow at math. If you want to do math faster, for example, or if you want to access low-level things, you might want to use something called a NIF, which is a bridge between stuff in the Erlang virtual machine and low-level code. Most people write NIFs in C. Rust is becoming popular as well. And I wrote Zigler so that you can write this thing called a NIF in Zig. I hope that's a good summary.
That's great. So thinking then back to 4 years ago, over the last 4 years-ish, what has changed with Zig? You mentioned in the intro trying to stay on to 1.0. Like where has Zig been going? Where has it been recently?
Okay, so unfortunately, the one big change in Zig that has happened since the last time I talked a lot about Zigler is that Zig removed something called async mode. So this is famously hard to do in JavaScript, famously hard to do in Rust. And it's like this thing where you can, you write your code and it can be interrupted at any particular point in time. And the problem is that an async, if you mark your function as async, only another async function can call it, unless you have a very painful bridge between the async functions and the non-async functions. So the joke I guess like Node.js is all async. So you wind up having all of your functions are async in Node effectively, right? I think also maybe an async function can call a sync function, but a sync function can't call an async function, if I recall correctly. Rust also has this as a huge pain point, and Zig had a half I would say actually 80% working async implementation. And there were enough like sharp edges with it that they decided to put a pin on it and come back to it later. So async has been disabled in Zig for the last 3 versions. It's probably not going to come back for another 2 versions, at least. Okay, so what does that mean for Zigler? So Zigler supported a whole bunch of different NIF modes. So this is maybe a little bit detaily, but when you call out to low-level code in Elixir and or Erlang, there is a requirement that you must come back, you must finish up what you're doing within 1 millisecond. And if you don't finish up what you're doing within 1 millisecond, very bad things can happen. And they're very hard to track down. Bug reports will not tell you that this problem has happened. And so there are a couple of escape hatches. One is called running a dirty NIF. Most people run dirty NIFs. I think it's even default in some of the NIF packages. I think maybe Rustler does dirty NIF by default. I could be wrong about that.
You're going to describe the name, right? Or why it's like that. Why is it called a dirty NIF?
Oh, it's called a dirty NIF because it's a NIF that's kind of dirty.
It doesn't behave.
It's designed to a lot. It's designed. Okay, yeah, that's a good question. I actually don't know why it's called a dirty NIF. I mean, it kind of like feels right. It makes sense to me. The NIF isn't the NIF. It doesn't behave, so you can put it in this thing that's designed to like to. So it's got a different scheduler, and it's designed to handle these cases where it doesn't do what you want. I don't know why they called it.
If nothing else, I'm here to ask the hard questions.
Yeah, no, that's a great question. Anyway, so called dirty NIFs. The restriction though is that you can only have 1 dirty NIF per core. Also, if you kind of overload the dirty NIFs, I think there's something where like the virtual machine can sometimes like not give a sort of a latency for, your P99s could get a little bit wonky, but it won't cause weird crashes. But if you exhaust all of your CPU power running dirty NIFs, you could wind up having, I guess, service level problems that are very subtle, and you may not even see it, so it may not matter. The other option is to run in a separate operating system thread and let the operating system manage the time between the Erlang virtual machine and what your NIF is. So Zigler supports doing it the normal way, which says, hey, you need to manage the 1 millisecond requirement. It allows you to run dirty NIFs, and it also allows you to run NIFs in its own thread. And changing between the different modes is literally just setting one setting on your configuration, and that's it. So you can flip between them, and it's completely transparent. So you can try the different ones out. Maybe one works better than the other, and so you go. It used to support something called yielding, which the NIF subsystem gives you a way to like call into a function and put a pin on it and say it's okay for you to come back later. And then when it comes back later, it starts it up again. Using Zig's async system, I was able to have that connect very nicely with the beam. Unfortunately, that has temporarily been deprecated.
Temporarily.
Until Zig brings async back, which they might not. So it might also be permanently. I don't know.
Okay, so that was my question, because usually when you hear about something being deprecated, you don't hear that being like on a hiatus.
Yeah, I guess
kind of deprecated.
Maybe deprecated is not the right regressed. Regressed is the right word. Yeah.
Temporarily, potentially, maybe forever.
Maybe forever regressed. Yeah. Turned off. I would like to see them bring it back. I understand like what the pros and cons of having an async system in a low level language. We'll see what happens.
So if I were to recap that, does that mean that if they don't bring back that feature of Zigler cannot exist?
Oh, no. Zigler can exist. It works just fine.
It's just that async feature.
You just can't do yielding.
Okay, cool.
Easily. You can even do yielding manually. And maybe if it never comes back, I'll include a guide on how to manually do that. But it won't be as simple as I'm going to flip a switch between these different modes. and my code will automatically like move into one or the other, other modes.
Mm-hmm.
Cool.
But that kind of goes into sort of the design philosophy of Zigler. So when I built it, I wanted exploration of all the different ways to run NIFs to be easy, and also to try and like remove all of the pain points, specifically pain points where it's easy to make a mistake. If you've ever written a NIF for Elixir or Erlang, you can't just take a C function and just say run the C function. When the beam calls into your NIF, you have to give it a function with a very particular signature that says what the arity of the function is, what the terms are that are going into the function. And there's also something called env, which is like where all the variables are allocated on the stack, the heap of the function. A whole bunch of like internal details of the beam are kind of hidden in this thing called env. And so you get the env, you get the arity, and you get the terms that are in the parameters. And then you have to manually unbox them. Remember how I was talking about how like, okay, computationally is slow because every time you do an addition, you have to unbox and box. You still have to unbox and box coming out of a NIF, but maybe you could chain like 20,000 additions together without having to do the unboxing and boxing. You can see where the performance benefit comes out at the end. But you still have to kind of do that manually. And there's a lot of things you might forget to do. Like suppose you have an addition of two numbers and the beam is not a typed, I mean, it's strongly typed internally, but like a term can be anything, right? So the function gets called with this thing that's just a term, but suppose you sent it an atom or a string or an Elixir string or a list or a map or a struct or whatever, right? You can't do an addition on that, right? That doesn't make sense. And if you forget to check, hey, did you actually send me an integer, you're going to have a big problem on your hands, especially when you're going down to the low level, because when you work at the low level, you can cause things like crashes. And so there's 100 different things that you're going to forget to do. And so what Zigler does is it builds all those things for you automatically. And before, when I said you can't take a function and just say, hey, beam, call this thing, and you have to build that like shim between the way that the beam wants to call into the low level versus what you have to do. So what Zigler can do is it can read the function that you've written and say, okay, these are the parameters that you're expecting. I can build a function that looks exactly like that systematically. And then it builds that shimming function for you. So in practice, when you run Zigler, you write a Zig function that has a signature that makes sense in Zig. And like, let's say you want to add two integers. You say, okay, my two parameters are two integers and my return value is an integer. And then it can read that function that you've written and says, okay, this function has this name and it takes two integers and then it returns an integer. And it builds all of the unboxing and boxing bits. And then it creates inside of your module a function with the same name as the function that you wrote in Zig. And that whole process to connect the two bits is done automatically and without error. So if you pass a map, then it'll say, I'm sorry, I need an integer. You pass in argument 1 a map. So it's very easy for you to see what the errors, what you did wrong.
Mm-hmm. So it sounds like if somebody is looking to add a NIF and has no reason to pick any one over any other, the advantage of Zigler and Zig is that Zig is lightweight, small. You could probably learn how to do what you need to do quickly.
Yes.
And then you've made the integration of that now faster math code really easy.
Yes.
And if I pass the wrong thing in, you'll give me an error message that makes sense and not, try to figure it out from the wreckage.
Yeah, exactly. So the other interesting thing is Zig understands C. So there's even a mode that I have called Easy C, where you can say, go read the C code, and it will build the shims out just as if it were Zig code. So you could potentially supply C code. It would have to be like a header file.
Mm-hmm.
And it would read the header file and it would say, okay, these are you tell it which functions. So C has a namespace that like includes the world. So you have to specifically tell it, like, because uh, so this is a little bit of inside, like, low level stuff, but in Elixir we have these namespaces that are modules, right? But in C there's no such thing as a namespace, so every function is exposed to every other function. So if it tried to read everything, it would dump everything into your module, which is not what we want. So for when you use C, you have to specifically say, please include these explicit functions, please. And then Zigler will read that and it'll say, okay, you made a function that like is the C function, maybe it's like a process audio file or something like that, right? And it will go find that function. It'll say, okay, you asked for a string, which is going to be the path, and then like maybe like how many seconds you want or something like that. And then it outputs a binary that is like the wave file or the wave data. And Zigler will know, hey, like, okay, you wanted this. This is a C function. That's fine. I can handle it. It will know that you need to pass like a binary for the path. And then it knows that for the return, it'll be a binary for the data. And it will know that it's an integer for how many seconds you want, for example.
What
Okay.
is the oh gosh, this is going to sound so high level. What is like the target market engineer? Who's reaching for this? Is it like the Elixir engineer who needs some assistance on some lower level things, or is it like a C engineer who needs some Elixirisms?
I actually don't know, but I know what I've used it for. So I used it in the last company that I worked at. And what we were doing is we were building custom LLM hardware. So you could load up like Llama 3 70B, for example, or Llama 3 8B, or Mistral or Mixtral, or pick your open source model. And the company had hardware that would basically do the math really fast. That hardware requires, because it's hardware, right? Like it requires like a low level interface. And I was able to interface that with the beam using Zigler to call in to the hardware. So the hardware developers all wrote C functions, actually C++ functions, but they were pretty easy to like mount into Zigler. I guess the question you could ask is, why were we using the beam, besides the fact that it was something that I knew? So we also had a load balancer that would present an API that looks like the OpenAI API. And hardware, especially bleeding edge hardware, can be unreliable, and it could choke on random situations. Maybe ran out of memory, maybe some hardware condition that we hadn't figured out yet got tripped, right? And we needed to do demos where, hey, like if this hardware kind of, carks it, either it presents like a reasonable error message, or better yet, the end user doesn't notice. And so the load balancer, which accepts the HTTP connection, would go and find a hardware unit over the network. So it wasn't necessarily on the same machine. In fact, we had the load balance for a lot of our demos. We had the load balancers up in fly.io. And we had machines in our data center that actually were the hardware. And the request would hit the load balancer, and then the load balancer would find the hardware. These were all in an Erlang network. It's weird. Like I always said, you shouldn't make asymmetric like network, but then I made an asymmetric network, and it was just fine. But the request would start streaming, right, and then it would start sending tokens back, and the tokens would be sent back up to the load balancer, which would send it back to the user. But if the hardware died, you get a node down message over the network, right? So because the process in the load balancer, which was running Phoenix, right, because that process had a so was it a link or was it a monitor? I think it was a monitor. It monitored the beam process that was managing the LLM request, and it could keep its state. So it remembered all the tokens that had gotten generated, right? So if this hardware down here blew up, it would know that something unexpected had happened. It would be able to redispatch the request with the so far completed tokens attached to it, send that to another node, and it would just keep going. And like there was maybe like a 20, 30 millisecond hiccup usually.
Mm-hmm.
And the end users never noticed. Like we had incidents where the hardware would go down and nobody was the wiser.
Mm-hmm. So you had your kind of like your fault tolerant, wonderful OTP stuff, but then we're able to interact with these low-level C libraries to get to the low-level hardware.
Exactly.
And so that was kind of the originating use case.
Yeah. So I really wanted to like schedule the individual matrix multiplies using the beam, which I think we could have done, but I just couldn't figure out how to. Like in retrospect, I know how to do this now, but I couldn't quickly figure out how to get NX to do what I wanted it to do. Although, like I said, in retrospect, it's just so simple. I should have, when you're in a startup, sometimes it's just like go, and like I had 100 things on my plate, so like working on this other idea was not a high priority.
And so why not just write the Erlang NIF in like for the C code that you already had? Like why introduce Zig?
Oh, okay. So I wanted a really fast token picker. So this is maybe a little bit of a detail of how LLMs work, but an LLM will generate probabilities for every token. And then you have to pick which token is going to be the next one that you send back to the user. And I wanted a really, really fast token picker. And I knew how to write a very fast token picker in SIMD. So SIMD is like single instruction, multiple dispatch. So this is a CPU feature where you can do like, say, 8 multiplications or 16 multiplications simultaneously. And the hard part is you need to do a top K sort on for most of the way, or the way that most people use LLMs, you need to do something called a top K sort. So you have all these probabilities. Say your token space is like 100,000 possible tokens. You have a floating point number for every single one of these tokens. And then you need to do a top K sort and find the top 150, or let's say 250 or 150 or like 100 or maybe even 16. I don't know. So you cut out all the chaff, which is like 99% of these, right? So like, or 99.9%, right? So like out of 100,000 possible tokens, you first want to see, I want to only know what the top 100 is. And then I'm going to pick out of the top 100, the one that I want. So that is really hard to do. With the standard C libraries, the standard C++ libraries are not equipped with the type of sort you need to do this.
Okay.
It's not hard to write, but it's also not easy. And I knew enough low-level SIMD that I could get that done. And so we wound up with a very fast token picker.
Okay, so Zig for your SIMD, for your token picker, and then also was great that you could just leverage the C code that went down to your low-level hardware.
Right, exactly.
Cool.
So that is one possible use case for it. One of the things that might wind up happening, I'm going to be talking to like robotics, biorobotics person soon. They have an open source, at least they claim it's open source. It's called Opentrons. It has open in the name. I don't know if it's actually open source. We're going to test how open source it is. Yeah. But it would be cool to like low level control some robots with like with Erlang. So that might happen, and I might once again be using Zigler to control some like low level stuff for robotics purposes in the bio lab. But we'll see.
So are these things that you couldn't do with Rust and Rustler, or you had a familiarity with Zig already, or where does that fit?
Yeah, I don't have a familiarity with Rust or Rustler, so that was easy for me to choose. I also know how to do SIMD and Zig, so that was helpful for that purpose.
If somebody's listening to this and doesn't know Rust and doesn't know Zig and maybe learned C 20-something years ago, like how approachable is Zig?
If you learned C 20 years ago, Zig is like perfect for you, because that's me, right?
Because you forgot all the bad parts of C and they're just not in Zig.
I never, use it hardcore enough to like ever get there, right?
Yeah.
To where I'm like writing insane macros. And if you're quote an old C head, you're going to love Zig. And maybe you like Rust too. Like, I don't want to say like, I think Rust definitely feels more like C++. It has like a lot of things that it does implicitly. And if you're fine with that, then by all means use Rust. It's also memory safe, which means that there's a class of errors that you can't get with Rust that you can get in Zig.
Right, because you're doing your own memory allocation in Zig. Right?
You do your own memory allocation. So I hold out hope that someday Zig will, not necessarily in the language itself, but come out with tooling that will tell you that you're not memory safe.
Mm-hmm.
At the end of the year, while I was kind of like decompressing off of being primarily a programmer, I did kind of like a little proof of concept where I tried to write a biochecker for Zig. I wrote it in Elixir because I knew that would be the fastest way for me to get the stuff done.
Mm-hmm.
And I was able to write a very rudimentary biochecker for Zig. And so I hold out belief that it is possible for biochecking to. It did more than just biochecking. I'm a scientist too, right? So like one of the things that I had it do was you could annotate variables with units. So you can say this variable holds the units of meters per second, and this variable holds the units of like seconds. And then if you multiplied a variable that had the units of meters per second and a variable that had units of seconds, it would know that the next variable that came out of that multiplication had units of meters. And if you tried to like add two things that have incompatible units, it wouldn't let you. It would tell you exactly where that error was, which units you tried to like, and it could also tell you where those units were set. Anyways, a little bit of a digression there. There was a little bit of a hobby project, but I just wanted to prove to myself that like a future for like memory safe Zig is a possibility. And I think, first of all, I don't advocate for anything like this to be written in Elixir. I just did it because I knew I had like a month and a half to just kind of mess around.
Mm-hmm.
And I wanted to do things quickly.
Sure. Well, we've all got that. Like when I want to do something quickly, what do I reach for, right?
What I reach for,
I've always
exactly.
got the one, whatever it is.
Yep.
We hope it's Elixir, but it isn't always. So on like a real world project where you're amassing like this Zig code, some C code, how do you keep things organized, CI, CD, any kind of like tips for teams that are going to start adding this in to like start to manage all these pieces?
Oh boy. I think there isn't one right answer.
Of course.
If you like have a tiny bit of low level code, so I guess this is kind of like one place where I took issue with how Rustler does things. You have to create your own cargo infrastructure around it, and it has to effectively be in a separate repo.
Mm-hmm.
I mean, I guess you could probably mono repo it somehow, because I think cargo you could do separate directories. Kind of shoehorns you into like this particular structure.
Mm-hmm.
With Zigler, the way I designed it was so that the primary use was for you to like write your code inline inside the module. So you never have to leave that single file to look at what's in your module. Now you can instruct it to go, hey, look at this file elsewhere. And if you have dependencies, you can certainly pull in like a different directory as a dependency. When I was doing the LLM stuff, we had a completely separate repo that was the C++ repo. And that just generated a shared object file. And we just made it so that that shared object file was mounted into the beam as well as as part of the initializing the module step. So your module would load, and then it would look for the shared object file, and then it would mount that into the beam, as well as the shared object file of the NIF. And that was actually pretty painless. So, but organizationally, that made sense because for what we were doing, like the teams were separate, right? So, if you have like separate teams for doing low level stuff versus high level stuff, you probably should organize it so that their code bases can be somewhat independent. And all you have to do is have like some contract between the two sides, like a header file or something would do great. But if you just like need like a handful of functions to be called, you should probably keep it in the module.
Just sigil Z it and call it a day.
Sigil Z it and go.
That needs to be on a sticker.
Sigil Z it and go.
Just sigil Z and go. Yeah.
I don't know if we're still in the trend, the era of stickers on laptops, but
I never really caught on to that.
yeah.
So you mentioned your kind of day-to-day involvement has shifted a bit, at least until you start commanding robots with Zig.
Yeah.
So, how is the community responding to Zigler? You mentioned you're going to stay on and try to support it through 1.0 and 1.0 of Zig. How is the community around it? Is there anything that you're looking for help with, or?
Yeah, I know some people are using it, but they don't really tell me unless they have an issue, and then I see new faces on the issue tracker.
Sure.
So I don't know. I actually have no idea. I haven't put much effort into community building, which is probably I should, because like if I hand over the reins at 1.0, I mean, like if I'm building robots with it, I'll probably just keep
going.
keep maintaining it. I also anticipate like a pretty high level of stability at 1.0. So it may not even need much maintenance. It may just be, you know, version up, done, right?
Mm-hmm.
Also, in my experience, the drift between Zig versions has gotten like smaller and smaller. Like the amount of time I've had to spend like updating the core infrastructure of Zigler to get it to work has gone almost down to like nothing.
Mm-hmm.
Like if there's like a handful of new bits of syntax in Zig, I might have to like add a couple lines to the parser.
Right.
Hey, recognize this new syntax.
It would just be things that affect how you bridge between the two, like
Right. So
like whether async is a thing, right? Like that
right,
kind of
exactly.
stuff. Yeah.
So yeah, that was the biggest one and I was just commenting out like this one feature. But I mean, I have spent a lot of time with each release. I've been spending more time refactoring my code because there's a lot of weird ad hoc stuff, and now with 0.14, like the way that all the options are handled and the error messages that you get if you misconfigure it is just much saner. So I'm like able to spend more time on like the user experience aspects of Zigler, which makes me happy.
Yeah, that's awesome. I mean, especially if it's not like in your face, your day-to-day programming life, the easier it is, the better, right?
Plus, I mean, like maybe I'm a sicko, but I love refactoring. Like, especially, I mean, especially if it makes everything like, that feeling.
Yeah,
Mm-hmm.
it's refreshing. I get it. So, our audience is primarily Elixir folks. Usually, we do get the odd one-off other language here and there. For Elixir engineers who are interested in getting into using Zigler and they've listened to this episode and they're thinking, Isaac just described 5 scenarios in which I think that applies to my life. Where would they get started? What resources are out there for them?
Right. So probably the biggest resource is the HexDocs repo. So if you go to if you go to Zigler in HexDocs, it'll point you to the main sort of documentation. And I think the most important thing to point out is that there's a whole section on the left called guides, which include, I should double check to see if there's like a how to get started. Maybe I should write a how to get started guide and release that with 0.14. The guides show you how to do a whole bunch of different things that you may not necessarily have known that you needed to do, or maybe not known that maybe that you didn't know that you could do. And all of the guides are tested. So all the code in the guides is guaranteed to be correct.
That's awesome.
Yeah. One of the interesting things is actually, okay, so I'm really excited about this. Mac OS is now like a first-class citizen in Zigler, and Windows is experimental but working, and FreeBSD is also experimental but working. There's some sharp corner cases where it won't work in Windows and FreeBSD, and they'll be documented. Okay, so I'm like, as of the recording, but probably before broadcast time, 0.14 will be released.
Oh, I thought you were going to say I'm going to have a how to get started guide ready.
Well, yeah, sure, that too. So I'm like 90% finished with the 0.14 release. There's just like one feature that I want to do, and then it'll be good to go.
And when you say support for those operating systems, is that like because of differences in the Zig toolchain on those systems?
So the Zig toolchain is the same on all of those systems.
Okay.
And so yeah, it turns out that Erlang is different on the systems.
Oh, okay. Well, there you go.
Specifically Windows. Windows was a little bit challenging, but yeah. FreeBSD was just like, that wasn't hard. I just couldn't figure out how to get GitHub CI working on it. And I didn't want to declare that it was supported,
Sure.
even experimentally, if I didn't have a CI badge. So
Yeah. Well, I got to say, the examples and documentation you have is just stellar. Like, this is first rate. I want to jump off this call and learn me some Zig and
awesome.
find some math I want to do really fast.
It's just remember about the 0.1 millisecond rule.
Sure. Yeah.
Or sorry, 1 millisecond.
Real fast. Yeah.
Yeah, real fast. But just make it threaded. If you're when in doubt, just make it threaded or dirty.
Right.
Dirty's good too.
Well, if Dan has a question, he knows who to reach out to.
Exactly.
But that's just Dan. What about everyone else? Where can everyone else reach out to you if they need to? Or do you not want to be found?
No. I mean, I think I'm reachable on Twitter, DNAUTICS. I'm also on Blue Sky, although I check that far less frequently than Twitter. I refuse to call it X. We call it Twitter.
Yeah.
I'm also on Blue Sky there, but I'm way less frequent there. And if you have no other mechanism, you can ping me on Slack, the Elixir Slack. But I probably check that with maybe a once a month frequency. Which is better than 0, I guess.
Yeah, that's fair. Any final plugs or asks for the audience?
Have fun with Elixir. For me.
Good advice.
No, I'm still having fun with Elixir. If you know of great markdown stuff, let me know.
Cool.
Awesome. Yeah, this was really great. Appreciate the deep dive walkthrough, and I think there's a lot to really like here. So I hope that everybody checks it out.
Awesome.
Yeah.
Thanks for having me on.
Thanks, Isaac.